Say you draw a 5-card hand from a standard deck of 52 cards. What is the probability that your hand contains a full house? So what is a full house? A full house means 3 cards from one rank and 2 cards from another rank. So for example, getting 3 kings and 2 fours would be a full house. Getting 3 eights and 2 jacks would also be a full house, right? And so we want to count, or we want to have what's the probability of this happening. And so the way we do that is we're essentially going to count all the possible hands. We're going to count the favorable hands, and then we will divide. So if we start by all hands, so how many hands can one have? So you have 52 cards, and you need to choose 5 of them, which means that there are 52 choose 5 ways of getting these cards. And so this is going to be the size of our whole sample space, right? So our sample space is all the ways you can have 5 cards. And so the size of that is going to be 52 choose 5. And now we count the favorable outcomes, right? So how many of these hands are actually, full houses? So for the favorable hands, so how do we do that? So first, or one way to count it is, first we need to choose the rank of the triple. So every time you have a full house, you have a triple, and that triple has a rank. So the rank is just the number value of the card. And so how many ways can we do that? Well, there are 13 different ranks in a deck, right? So the numbers, like, they go ace, 2, 3, 4, 5, and then up to 10, and then jack, queen, and king. So you have 13 of them, and you need to choose one, right? Then once you've chosen the rank of the triple, you need to choose, the suits. So if it's hearts, clubs, diamond, right, or spades. So now we need to choose the suits of the triple. So how many ways can you do that? So there are 4 suits, right? And we need to select 3 of them, because each one of the cards in the triple is going to have a different suit. So we need to select 3 of them. Well, with that, we select our triple, like the 3 cards completely. We need to do the same for the pair. So now we need to choose the rank of the pair. And notice now that the rank of the pair cannot be the same as the rank of the triple, because if not, it wouldn't be a full house. It has to be a different one. So we don't have 13 choices anymore because we chose a rank for the triple. So now we have 12 choices to select from. So we're going to choose out of those 12. And then we need to choose the suits of the pair. So now again, you have the 4 suits, and you need to choose 2 of them. And to get the result, and so our answer here is going to be the multiplication of all of these. That's going to be the favorable hands. So it's going to be 13 choose 1 times 4 choose 3 times 12 choose 1 times 4 choose 2 divided by the size of the sample space, 52 choose 5. And if you compute this, you're going to get 3,744 divided by 2,598,960. Of course, recall that n choose k, you can compute it as n factorial over n minus k factorial times k factorial. And so the probability of getting a full house when you from a deck of 52 cards is gonna be this number here, which is approximately, just for us to have an idea, 0.00144. So it's approximately like 0.1%.